Yes, hi everybody. Ja, velkommen til GeoOnsdagen igjen. Her ved Realfagsbiblioteket ved Matnadsfakultetet ved Universitetet i Oslo på Blindern. Mitt navn er Bernt Etzelmüller, og jeg er instituttleder ved Institutt for geofag her ved universitetet. Og i dag skal vi lære mer om klimagassutslipp fra Antarktis, et svært viktig og eksotisk sted. Og det er derfor en stor glede å kunne introdusere Adriano Mazzini, som står her. Adriano er geolog og forsker på prosesser i sedimentære bassenger, spesielt transport av væsker og gasser i de. Han har en master i geofag ved Universitetet i Genova og i Amsterdam fra 1997, og en PhD fra Universitetet i Aberdeen, UK, i 2004. Han dro så til Oslo for å ta en postdoc ved PGP Geo, som nå er Nordsenteret, i 2005, og er siden 2013 tilknyttet SID. I dag er han tilknyttet bassengseksjonen ved Institutt for geofag som forsker. Adriano er interessert i hvordan væsker og gasser beveger seg i øvre jordskorpe, og også hvordan dette påvirker miljø og klima, for eksempel gjennom avgassing fra havbunnen. Han har vunnet en IRC Starting Grant med mattvulkanos i 2015, og er generelt interessert i mange anvendelser av marin geologi og gassutveksling på land. Og i dag vil Adriano ta oss med til Antarktis og presentere Antarctic Permafrost degassing. So, the floor is yours.
Thank you. Welcome, and first of all, thanks for the organizers to inviting me again here. It's always a pleasure, and thank you all for coming, and also all the audience online if there is someone attending the seminar. I was told not to put too much scientific aspects on this presentation, so I stripped off some slides, but I included many others, and so I added an additional title on the way to Antarctica, some storytelling and fun facts and how we did it. I guess for maybe several of you that have been in the polar expeditions, all this is nothing really new, but maybe for others can be inspiring and can be interesting for you to follow. So what I'll do for the next 40 minutes or so, I will try to entertain you with some selected results and some pictures, some stories that we had during our expeditions in Antarctica. And these expeditions are actually part of the Italian project called Seneca. Is sponsored by the Italian National Program for Antarctic Expedition, and it also includes a consortium of several universities from Italy, from Europe, and of course from Antarctica. Antarctica New Zealand was our partner, local partner. We used the Antarctica base and their logistic support and everything. So what I'll show you is also not only my work, obviously, but is the result of a joint effort of many people. But before we go to Antarctica, I will tell you what implies going to Antarctica. If you are enrolled in the national Italian program. In that case, they have rather strict selection protocols in order to go there, which I kind of like. First of all, obviously, you need to prepare your proposal, has to be evaluated, and has to be successful, and you need to win the grant. Then you have to do one full day mandatory medical. It's a full screening at the military medical center, and then you have to do 2 weeks of mandatory survival course. Again, it's 1 week at the Brasimone Training Center, theory and practical, and then you go to Monte Bianco for another week. Then, if you pass that, you have some bureaucracy issues, some legal, some criminal records checking, some visa, and so on. And then, if you're lucky with the weather, which is not always given, you are able to reach Antarctica. And if you're also lucky, you can fly back. So medical selection screening at this center includes everything. They check everything of you, full body checkup, blood, urine, dentist, eyes, nose, hearing test, cardiologist, cardio under stress, spirometry, nephrologist, X-ray, Minnesota test is this 600 questions where they ask you some weird questions like, I don't know, you like flowers, or sometimes you walk on the street avoiding tiles of a certain color and things. Then you go to the neurologist and the psychologist. If you pass that, which is not given actually, you may go to do your survival course. So the survival course is, the first week is at the Brasimone Center, is a dismissed nuclear power station close to this beautiful artificial lake. And there you have, for 1 week, or every morning, you have lectures. And they teach you pretty much everything about Antarctica. It's very interesting from scientific point of view to safety point of view, how to behave in the base, how to do the transfers, how to weather conditions. You have this very strong katabatic wind, what to do in this case, and so on. So it's how to use instruments and so on. In the afternoon, you have practical activities. And they actually begin from very simple things, trying to build up your expertise in order to be somehow ready to face your participation to an Antarctic expedition. So they start from very basic things, how to mount tents, different types of tents, simulating ice conditions, how to position the tent, I don't know, depending on the direction of the wind, the dust, and so on, if you have ice, if you have snow, if you have different types of snow, and so on. Then you do, of course, first aid training courses, how to use communications, radio, how to operate with the radio, how to talk on the radio, how to repair simple things on the radio, simulate some escape situations from dangerous environments, how to use this ladder, which is not really trivial, how to use ropes, how to break things if you need to run out. Then you do firefighting. They dress you up. You need to know how to use different types of fire extinguishers, when to use them, how to walk in the fire covered with a safety blanket and come out alive, how to use the ooze for firefighting. They lock you down in a container with no windows, blindfolded. You need to find your way out, climb up and go down, simulating that there is no electricity, for example, in your thing. They teach you how to use all this equipment. They dress you up, and you need to go all the way up to the cliff and come all the way down. They teach you knots, how to use rope, which rope to use, how to use it, carabines, and so on. How to drive and use a Zodiac at full speed, how to park it, how to dress up wetsuits. Then it's all organized by military people, actually. It's very, very well disciplined. They throw you overboard of a Zodiac. They teach you how to jump back on your Zodiac. Then they throw you, all of you overboard. And then you need to lock each other and swim all the way back to a safe place. And then next step, you approach the Alps, and you go very close to Monte Bianco, and you, again, organize your tents. You build your tents, you build the common tents, you organize your luggage, you build your kitchen, everything. So they teach you how to live in community, in conditions that are still acceptable, but they're still in community. Not everybody can do that. Not everybody is familiar to go out of the comfort zone of your own toilet and use common toilets. And so some days are really beautiful. It's a very nice place. Some days are not so good, and you may begin to feel miserable already while you're on the field. Then, with the helicopter, they take you all the way back to Monte Bianco, to the top. Very nice helicopter ride through the glacier. And once you are on the top, this very skilled pilot goes back to base, and you are left there on the glacier, and they teach you how to put nails in the ice, how to build up connections with ropes, how to walk all together through crevasses. And then, you keep on walking through several types of snow, several types of ice, and you go all the way down. And then you come back, so you also test your training facilities through the ice and the snow. Then for some people that go to remote camp on some specific conditions, you organize a camp on the glacier, on Monte Bianco. Some days, again, are very beautiful, and you're stuck there. And some days are not so beautiful. But that actually is very useful, because together with you, there is all these people that are actually checking your attitude, your behavior, and before the end of the course, they may tell you easily that this is not really something for you. You may not be able to go to Antarctica because, or even yourself, you realize that if you cannot survive 1 week in some conditions, once you are in Antarctica, you're stuck there by yourself. There is 150 kilometers away from the closest base, and the only way is the helicopter to pick you up and bring you back if the weather conditions are good. So, if you fulfill all these requirements, if you tick all the boxes, and if you survive this elimination game through all this, then you can finally go to Antarctica. And we're finally approaching Antarctica. Again, this is our base camp. And I will show you only some of the results of our expedition. But in order to contextualize this and the motivation for us to go to Antarctica and do this kind of job, I will give you a few slides. Again, perhaps redundant, because many of you know all this. The CO2 concentrations are dramatically increasing. We're approaching 420 ppm. Use of fossil fuels is increasing. And this has been going on for at least the last 70 years, if not more, where if you look at some of the parameters, the Earth system trends and socioeconomic trends, we consumed more carbon dioxide, paper production, water use, transportations, tropical forest loss, I mean, you name it. And there is several tipping elements for the stability of our planet, and which I will not go too much in detail here. There's no need for you guys, but we have this Antarctic amplification that can cause further damage to the stability of our planet. For example, one of them is the positive feedback loop that you have when you start melting the ice, and as you melt the ice, you have darker oceans, so the water absorbs more heat that remains in the water, and then you increase the water temperature and you will melt more ice. And this is very clear that more and more ice loss we're having in Greenland, for example. Consequences are several, just to name the thermoline circulation alteration. So doing so, we alter the currents that can, again, enhance warmer water to approach to the north, or the weakening of the jet stream, where, again, it's shifting towards the north, again, amplifying the temperatures in the Arctic and Antarctic regions. And if you focus on the Arctic, we have clearly ongoing permafrost thawing, a lot of evidence of permafrost thawing in the coastal areas, coastal instability, giant pingos appearing. There's a famous one in Siberia, or in North America and in Siberia, these degassing craters. And again, this is important because Arctic and Antarctic regions, they store almost twice the amount of carbon that is present in the atmosphere today. And if we increase the temperature, we will melt more permafrost. And melting more permafrost, we will release greater and greater amounts of CO2 and methane into the atmosphere, which again will contribute to the acceleration of the global warming. So we need to kind of get out of this vicious loop, hopefully. Otherwise, things can only go worse. And the same is happening in Antarctica, where we have gigatons of ice per year that are lost and gradual sea level increasing. And we have huge amount of permafrost, obviously, in Antarctica, which is now covered by ice, but that's potentially can be released once the ice melts off. So that's the motivation on try to understand what is happening in Antarctica, which is a less studied region compared to the Arctic regions. There is very few investigations to quantify the amount of gas that is coming out. But we have, again, huge permafrost volumes. So to go to Antarctica, for us, it's a long way, especially for me, from Norway all the way to Antarctica. And the last destination before we go to Antarctica is Christchurch in New Zealand. And you move from a situation where it's full summer in New Zealand, and then you have to dress up fully to board the plane already in Christchurch and stay pretty much like this all the way throughout your flight. Not very comfortable flight. It's a military airplane. It takes about 9 hours. It's C-130, and you have what they call go, no-go zone, because the fuel is limited on the airplane, and because the weather conditions in Antarctica are not always very predictable. Once the airplane reaches a certain distance, they will communicate with Antarctica, and they will tell if the weather conditions are good enough or not, if they changed from the departure moment. If they did, you fly back, and that happens very frequently. If they don't, you go and hope for the best. They will not change and stay very good. So once you are in Antarctica, this is some picture of the Antarctic bases, but we were here in the Scott base, the Kiwi base. Very nice base, very nice people, very comfortable, and it's very close to the dry valleys. It's also very close to McMurdo base, it's the largest base in Antarctica. But we were very close to the dry valleys here. It's the largest ice-free surface in Antarctica. You have very low temperatures throughout the year and very low precipitations. It's very, very windy, which also affects the temperature that you feel, actually, with more wind. And the cold and extremely arid climate don't really help. But dry valleys are part of this asthma category. If you look at the manual, you have very nice descriptions and everything, but the bottom line is that this is probably one of the, if not the most protected area on the planet. You cannot leave anything there. You should leave without leaving anything about you or without having your presence being noticed. So that makes field camping in this place, which is not nice by itself, even more complicated. So we had 3 expeditions focusing on different type of topics, geochemical data set, geophysical, petrographic data set, depending on the year we were part of. So you take the helicopter from Scott Base, and they drop you off, and they leave with all your gears. And that's there by yourself, and everything seems very close, but in fact is not so close. You have 10 kilometers wide valley, very high mountains around you, very big rocks, many, many rocks. And from day one, for reasons that you will understand soon, you will realize, we did realize, that your best friends are the wet wipes. Because you have no access to any water. Even if the streams are active, when it's not frozen, you cannot use the water. You can only collect it for drinking, if you want, but nothing else. And of course, you cannot leave any other type of water. So the base camp, it's like this. You have your accommodations and a common tent where you do some cooking and some things. You have big blocks, seems close, but is in fact 2 kilometers away from the glacier. This is not the guru tent, but is the toilet. And every morning you leave visiting places that you preset and decided the day before. And you have your rucksack, and it's pretty heavy. And you have instruments inside, batteries, spare batteries for the instruments, water, GPS, camera, radio, spare batteries, your food, first aid kit, notebook, and the pee bottle. You will see in a second what the pee bottle is. But you have to carry all this stuff with you every day. And you go up and down for kilometers and kilometers every day. What we did, we collected data from a geoelectrical survey, permafrost sampling, soil and gas sampling. We measured the degassing output, soil petrography, and the idea was to measure the seasonal trends, to repeat the measurements another year. So what I'll show you today is mostly the data collected from this grid. It's 160 points, and on each point we collected soil gas, CO2 and methane fluxes, radon content, and then in other places we collected sediment sampling and permafrost sampling. When it's not frozen, we could access the lakes and the streams, measuring some parameters for the water, for further studies, and to see how the water composition evolves, beginning from the glacier all the way to the outlet of the streams. Water collection for our use was not always very easy, because you have your glacier, and you have the streams when they're active. They gather in these lakes, and then you have an outer stream here, which is where we were collecting water, building some constructions to make it a little bit deeper and collecting some water for us to drink and to cook, until the pH became not acceptable, and then we went to visit the lakes, and we realized that they were full of microbial colonies, and they thrive very fast when the temperatures are rising inside the lakes. So that's the water we were drinking, and we opted for the option to glacier blocks. So we had to walk to the glacier, collect the blocks, melt the water, and then we could use it. So it's very laborious operations. We also installed some long-range probes installation that were collecting data. They were inserted in the ground until you reach the top of the permafrost. The permafrost is 20 to 40 centimeters deep, the top layer, and we were measuring concentration of CO2, temperature, humidity. We have about 3 years of data. Bedroom, this is our bedroom. Very, very basic. That's it. You are there, two of you, in your bedroom. Instead, the common tent has a heater, some area to work, put your data in the evening, radio, some cooking area, same cooking area, but at the end of the day is not so warm, because the stove produces CO, and you have to leave both of these hatches on both ends of the tent open to have the air circulating, and you have this jet of frozen air zooming into your tent all the time, so it's not that warm inside even this tent either. We collected soil and permafrost sampling. The idea was to do some parameters for petrography and sample the permafrost at different stratigraphic units. The goal was to see if there is a correlation between TOC content, which is anyhow very low, and the gas content in the permafrost, and to identify potential volume of gas that is released by a volume of permafrost that you sealed in your container, so you can scale it up. So we know that once you thaw this permafrost that we sample, we have CO2 and methane after thawing inside the sealed bottle. Some funny aspects about day life. If you need to brush your teeth, of course you cannot do it outside, but you need to collect all your waste in special bottles, which makes this operation very unpleasant. But what we were doing, we were again inserting these metal straws into the sediment until we reached the top of the permafrost, and extracting the gas and measure the composition directly in the laboratory in Antarctica. Someone asked me about toilet facilities, so here is your answer. This is your containers where you collect all your waste. Inside it's very comfortable. As you can see, you have everything. And you have, someone also asked me, the pee bottle. which is this bottle, which is always with you. No matter where you go, you leave in the morning, you come back in the evening, and this is your pee bottle with you all the time. So you leave in the morning, and you think you will be lighter in the evening, but it's definitely not the case, because you have to bring the bottle back and empty it in this containers. And when it's stormy, you still need to visit your fantastic toilet, no matter the conditions you have. So once these things are full, sometimes the helicopter is coming, collecting them, giving you maybe some food, and the story continues. So what we measured is the flux of CO2 and methane using this closed chamber system. You basically put it on the ground. You measure how much methane and CO2 is released by macro seepage from the soil. It goes through the sensors and comes back. So you can measure through time how much is the volume of your gas that is released. And doing this grid, you can actually scale it up. The same concept, you can do it measuring the soil gas content. And then I'll show you again this grid that we have seen before of all these points. And if you put all the data together, you can construct these kind of maps where you have concentrations of methane, CO2, helium, or flux of CO2. Some values are quite high in terms of methane, CO2, and CO2 fluxes. This is the flux. And if you put everything together, you realize that we have some multigas anomalies that are highlighted in red here. If you're curious, these are the parameters that we're looking at. But these anomalies are located on the shoulders of your valley, and indicating, suggesting that at least in this area you have a preferential pathway for fluids to release. Of course, you have anomalies also in the center, but the highest values, that's where you have them. And the same goes for radon anomalies. If you build the same map, you will realize that large part of the radon is released on the shoulders of the valley. If we compare with previous data of measurements that were done, but again, these are one single measurement only compared to 160 measurements that we did, but we see a gradual trend. This is our study. So through time, we have higher emissions of CO2. And I'm afraid that this trend for the next measurements could increase in the same direction. So we measured in the nearly 22 square kilometers is 1,300 tons that are released only during the 3 months of summer that we were surveying. In order to understand the subsurface, we also did deep electric resistivity tomography. We were carrying around these heavy reels of electric wire through the valley. We had a generator to produce electricity, to inject at several points. Again, same story. You leave in the morning with your rucksack, you cross the rivers, up and down, on the hills, with your wire and your electrodes. And we produced 5 lines of geoelectric. Okay, the goal was to investigate the sediment properties, the permafrost-based structure, and calibrate the results with the available borehole that is here. Shortly, these are the 2 first profiles. We have a quite big range in resistivity. We have highly conducted surface units that are associated with the presence of brines. These are resistivity below 100 ohms. And we have low conductive units with higher resistivity in these areas, which are related to the presence of permafrost. And the next 2 lines are located up here. So the farther to the east we move in the valley, the thicker our permafrost will be, as you can see. And we think that this is related to the fact that once the whole valley, our lake is somewhere here, this blue lake here, but the whole valley was filled by a huge paleolake, the Washburn Lake, which was basically dammed by the Ross icy shelf here. And during the retreat of the icy shelf, the lake also retreated and decreased in volume, and that's where we have the thickest portions of permafrost towards the northeast. So we produced a model for permafrost distribution and fluids. We suggest that there is two factors that contribute to the distribution of the permafrost and the fluids migration. One is a bottom-up process. Okay, so it's a permafrost is melting as the deeper brines migrate upwards because we remove the load of the ice and the lake that was before on the top, and this unloading caused the release of overpressure fluids at depth. And then we have a top-down process because we know that the temperature is gradually increasing, so the active layer of our permafrost is actually deepening and is going deeper and deeper. So we melt more and more permafrost. In 2021, we also did an additional line, actually crossing further to the north and to the south, the edges almost perpendicular to the axis of the valley, and went through this anomaly zone, intersecting also the basement that is framing our valley. And what we figured out is that the edges of the rocks, metamorphic rocks on the edges of the valley, are actually promoting the migration of fluids towards the surface. This is where we have most of the anomalies, which makes a lot of sense. Of course, we have some anomalies here related to streams and some local anomalies in the center, but this is essentially it. I'm not sure how I'm doing with the time, but we are basically approaching the end. If you want to know more about some of the results, this article recently came out. And you can look at it. But what we know is that we have methane and CO2 that is present in the permafrost. We know that from measuring the samples. We have a deep origin of the fluids that are overpressured from deep brines and reach the surface. And we have these layers of saline units within our package. We propose two mechanisms. Again, the melting of the permafrost, melting and erosion of the permafrost from below during the upwelling of pressurized deep hypersaline groundwater due to the unloading history of the area. And the warming climate induces the thawing, and it's deepening the active layer of the permafrost. Again, the preferential pathways are these tectonic discontinuities on the shoulders of the valley. And we estimate that we release about 15 tons a day, only in these 22 square kilometers that we analyzed. But again, you can scale it up, obviously. But most important, these measurements can be used for benchmark for future measurements. So if we repeat the same measurements, we can see if the trend is stabilized or is increasing or even decreasing. So to sum it up, some days in the field are really beautiful, but many days, most days are maybe not so beautiful and cold, definitely cold. You have a lot of mummified seals in the valley. These are kilometers away from the shore. You have sometimes some really interesting view scenarios that you wonder if you really are in Antarctica with the dunes. And you also do some climbing, so actually what we learned during the survival course it becomes useful, and eventually you reach the top. You can also do some crevasse visiting. You go all the way down 25 meters to visit this crevasse. It's 100 meters long. Probably shouldn't do that if you suffer of claustrophobia. But we also did skiing. It's probably the only ski station in Antarctica, but we managed to go there for a short time, and I didn't need a survival course for that. But some things To conclude, some things you may not like about camping in Taylorweiler: you have no showers. But again, you can survive without that. You may end up eating expired food. You have cooking limitations. Toothbrushing is not really great. You have clay everywhere, in the tent, on you, in you. And you have mandatory sunscreen. I don't like creams very much, but you have to use it all the time, and including hydrating creams. You have light 24 hours a day, no bed. You may have ice inside your tent, cold feet. You need to go and collect water every day, back and forth. You have bad weather, unfortunately. You have a lot of work to do, because when you go back in the evening, then you have to load all the data in the system, plan the day after, and so on. So it's kind of tiring. Some things you may not know: you can ski in Antarctica. I didn't know that. The rivers in the dry valley actually flows towards the inland, because you have the Ross Shelf, so they flow opposite to what we normally know. The age of the mummified seals and the penguins in the valley remains debated. Astronauts are training in Antarctica, and the dry valleys are probably the most environmentally protected place on the planet, and one of the most inhospitable places. And some people say that if you return from the dry valleys, you may be considered as a hero. So some things I learned finally: you have to be very patient, especially if you are in this kind of extreme conditions. Human resilience is surprising. We can actually adapt to many harsh conditions, and our limits are beyond what we expect. Teamwork is crucial, and showers are not essential, but you never know when you can, and if you can, come back from Antarctica. Hold on your friends, and Antarctica is a really special place. Overall, no limits. And that's how we did it. Thank you.
Yes, thank you very much for this magnificent presentation. Both science and non-science experience. I wonder why you're doing this. It's like a prison. Have you done something wrong here, so that is this a sort of a straf, punishment?
Yeah. Yes. Self-punishment.
Okay. Let's hear if there are any questions.
I'm interested by the Commonwealth Glacier. The front of it is a very steep cliff, and I've only ever seen that on glaciers that go into the sea. So what's causing this really sort of abrupt terminus at the front of the glacier, if you know?
You mean this? Yeah, it's very typical apparently in this area to have this abrupt end of the glaciers. The Ross Sea is actually behind us in this case, but then you have a ridge, and then it goes all the way down. But here you have the Canada Glacier is exactly the same. Here you have another glacier. Here is exactly the same. That's how it is. Yeah.
But no explanation. I guess it's something with the temperature.
But you are the glaciologist, guys.
Yeah.
you should tell me. But I know that it's typical. I also asked the same questions. And no, it's like this here. Okay.
Okay, and a new question back here.
So how much is the air? I don't actually know. How much is the air temperature changing down there? Because I mean, we have Arctic amplification, but not Antarctic amplification yet, right? So how much? So is it just global average 1 degree type of warming, or is it more?
You mean during our visit, or?
No, just generally, because you're talking about one of your hypotheses for the changing of the loading is just melting from the top, so higher temperatures. But how much higher are the temperatures?
Not much. I mean, but one degree or so is enough. And then again, it depends very much what period of the year you measure this. Of course, we did our best. We stayed during the summertime, but even during our time frame, we had temperature changes of even 10 degrees. I mean, it can be very, very big temperature changes. And that, of course, affects the permafrost. And in the last season, the temperatures were definitely much lower than during our first season. So, yeah, it's different, it varies.
In general, the Antarctic change, I think, is less than the Arctic change. And the active layer is only 20 centimeters or 30 centimeters. So if there is a thawing of permafrost from above, it's only centimeters. It's not meters or something like that. So it's much less. Okay, here, more questions.
Thanks for a fascinating presentation. Could you elaborate a little bit on the origin of the carbon in the CO2 and the methane? It's not coming from organic matter that is thawing and degrading. It's more like a fossil source. Is that right?
Yeah, we have some isotope data that came out just now, basically, and we have evidence of deeper sources. Yes, thermogenic methane, for example.
So there's no photosynthetic
There is basically nothing. There is very little. But what you do have is in some areas where you have, for example, here you have some streams, and that's where you have this microbial colonies that are very active. So the idea is to frame down all the areas which are interested by the water flow, lakes or water streams. And that's where you have these microbial colonies, which are now trapped inside the permafrost. So when this will melt, you will have even higher volumes. Because, I mean, overall, I mean, this is all debris, glacial debris, and the organic content is very little, especially if you compare it with the Arctic. So the comparison doesn't really stand. But if you focus on the areas where you have these microbial colonies which are now frozen and trapped in the permafrost, then you have higher amount, and that's where you have the microbial component. Otherwise, especially on the shoulders of the valley, that's where you have deeper origin gas.
This is a very remote place. How do you do it with telecommunication? Like, are you communicating with the Scott station, or are you worldwide out with satellites, or?
Yeah, we have, it's true, it's very remote, so every day we have, every morning we report to the base. There is a bridge with antennas, radio antennas, that eventually you end up connecting with the Scott base and reporting if you're still alive and if everything is fine. But we have satellite phones, of course, in case of emergency.
So, Adriano, how long will this Seneca project last, and will you go back again to Antarctica?
The Seneca project technically finished, so that was 3 seasons. Now we'll see. We submitted another proposal, but it's under evaluation.
Okay. Here's one more question.
And if you had to go back from Italy with another project, would you have to go through this whole training thing again, or are you set?
No, it's valid. The medical you do every year. The medical is mandatory no matter what. But the survival course is 3 or 5 years, I don't remember. And then you have to do some refreshing, maybe not the whole course, but at least they kind of condensate in maybe 1 week only. Yeah.
Okay, now it's 1 o'clock. Then I again say thank you to Adriano for this fantastic talk. Give him an applause.
Thank you.
And then I say thank you here from the science library again, and I don't think we have more presentations before the summer, but after the summer in September we will come up with some new people who will present to you. Okay, well home.